I'm Dr. Komilian, and I'm the course leader for Electrical and Electronic Engineering. And today we're going to be showing you around the Power System Labs at Staffordshire University. We start off with some of the equipment we have for testing relays and electromechanical system protection, as well as measurement equipment. We are going to be using Omicron CMC 356, which is industry-grade standard piece of equipment for testing. A lot of companies will use this. We use these in our classes to teach the students how to set it up and how to actually test relay systems under real conditions. We can also follow up with what the actual room in R118 is. Here the lab is divided into three small sections where we got the motor drives and electromechanical machineries. We've got system faults and three-phase systems where we can test out the three-phase. I'll go in every stage with you guys to just show you what we have in this virtual tour. So here we have a AC motor drive where it's got some sort of a load onto it. It's a mechanical load. And what we can actually test it through using the drive and measuring it, it's to see what will happen with the actual machinery itself when it's under high pressure load or high pressure torques, and how would the electrical system behave when it needs to pull out more current or voltages through the system. On the other side, we also have how we can actually generate three-phase systems. We using a DC motor to actually spin off a three-phase generator. The students can actually see how a three-phase system is produced and whether each sort of phase is synchronized with one another or not, and by varying the parameters in terms of the shaft and the drive, they can actually learn how we can control the three-phase. Moving on to the three-phase system itself, where like transmission lines and substations, we do have for power system engineering a replication of real size where we could tell them of or teach them in terms of how they can actually build a three-phase star-to-star or star-delta transformation, stepping it up or stepping it down and going through balanced faults and unbalanced fault systems. So in power system engineering, as we can imagine, things are changing from 20, 30 years ago. More intelligent systems are coming into the grid itself, and hence why we're calling it smart grid. Integration of renewable energy systems with Internet of Things, where all different equipments need to communicate with each other, including substations and microgrids and small grids that's got. The systems become more and more complex. In order to be able to design a new system quite cost effectively and cheaply, we use simulation systems, but using a computer simulation only will have its own ups and downs. So hence why we use equipments that will allow us to be able to do real-time simulation, such as Opal RT technologies, where we could design our system using a computer model and then upload it into this sort of piece of equipment and actually run it through a real-time simulation where it will be much faster to replicate and design the system and also test it for any potential faults. So now we're going to be looking at the HV cage, where it has the capability of doing 50,000 volts test, where we will look at the suspension and the pressure that it will put on the insulators. Basically, we do a lot of insulation tests here, whether it would be air gaps or the insulators on the suspension line or transmission lines. We got a few things that we implement this into research, as well as our teaching facilities and teaching methodologies that we go through with it. So soon I'll be doing a very quick demo for you guys of showing the breakdown of air gap. It's quite safe. Everything has been earthed in here. So I'll just quickly set up the connections for a very quick demonstration of air gap breakdown. Now we need to unearth the transformer and connect the earth back to the cage. The system has a lock mechanism where it won't allow until you've made sure everything's secure before you actually can switch it on. We're going to reset the system in order to be able to do the test. System is ready. We could start increasing the voltage and you'll be able to see the actual air breakdown. We're at 5,000 volts, 10,000, 20,000, and the circuit breaker has tripped. Safely switching the system off. what we could do, or the students with the help of our technicians, they were able to actually modify the distancing into the two electrodes that we've got going on there. They could also replace it with other materials, and also they could test what sort of pressures will actually be put on the suspensions and the insulators on the suspension itself. Thank you very much for joining me today to do a virtual tour of the Power System Labs. I'm looking forward to seeing you all either online or on site. Take care, bye.